Woohoo, we are live. Yay, I'm having some difficulty with my focus. There we go. Woohoo, this is Math 40. This is section 4.2, solving systems of equations by substitution, page numero uno. And we're going to go right into it. And because I think this is better taught just by experience, I'm just going to go right into it. Knowing that you don't know what substitution is, I'm going to show you what substitution is. So we've got a system of two equations. And in the last section, we were talking about coming up with solutions either by graphing it or by looking at ordered pairs and seeing if they match up. And this time we're going to use algebra. So instead of graphing, there's going to be some exciting, okay, pardon me for just a moment. There we go. I'm so sorry. There we go. Okay, sorry about that. The focus, it decided it was going to try to change the focus. Are we okay now? We are okay now. Good. Okay, so we've got two equations. They're both linear. So I've got x and y in both of them. No x squared, no y squared, no square roots or anything funny. And what I'm going to do is I'm going to number these 1 and 2. I've got two equations. And equation number 1, I'm going to write out right here. X plus 4y equals 7. Now, this equation on its own gives me a whole set of x's and y's that go together. And so it's impossible for me to find a single answer because this has a lot of answers. In fact, this equation has an infinite number of solutions. So what I'm going to do is I'm going to take the second equation and try to combine it with the first equation so that we can find out whether Matt Damon is going to make it off of Mars. We're going to find out whether we can allow him to keep breathing in his spaceship and also not burn up on re-entry. So we're finding that golden magical point that lies on both lines. I noticed that this second equation has x equals 6y minus 3. I've solved for one variable. And if x equals 6y minus 3, then I can look in the first equation and say, wait a minute, I see an x there. What if in place of x, I put 6y minus 3, which is equation number 2? So basically, I've taken equation number 1 and I've stuck equation number 2 inside it. I continue with the rest of equation number 1, sorry, and I notice that now I have an equation that is all y's and numbers. So now I can go ahead, 6y minus 3 plus 4y equals 7. So let's see, I've got, there's my handy dandy highlighter. I've got 6y's here and 4y's there. So altogether, 10y's. 10y minus 3 equals 7. Okay, so now what can I do with that? Well, among other things, 10y minus 3 equals 7. I can add 3 to both sides and get 10y equals 10. Or 10y divided by 10 equals 10 over 10. So y equals 1. Ooh. So to recap, again, what did I do? I took the first equation, and then I took a piece of equation number 2 and I plugged it in where the x was. And that gave me a single equation that kind of has, it's kind of like their baby. I took them together and I created their child. And this child equation has information from both equations. And then I was able to solve this and find that this special situation happens when y equals 1. Now, the thing is for this to be a full solution, I need to know x. So let's go back. Now, I've got two equations up here. I like this one, x equals 6y minus 3. And when y equals 1, x equals 6 times 1 minus 3. So that's 6 minus 3, so that's equal to 3. So I think I have the equation, or sorry, the ordered pair 3, 1. Now, what in the world can we possibly do if we are in the middle of a math problem and wondering whether we got the correct answer. You got it. We can check. Shall we check? So here's my the first problem, the first equation. Oh, my mouth is all over the place. And the second equation, x equals 6y minus 3. So what I'm going to go ahead and do is I'm going to check both of these. The coordinates we were interested in was 3, 1. We believe that that's the golden point that will satisfy both equations. So let's try the first one. This would be 3 plus 4 times 1. Does that equal 7? So that's 3 plus 4. That equals 7. Woohoo! Yay! It works. Okay, let's check number 2. 2 says x, so that's 3, equals 6 times 1 minus 3. So all I'm doing is I'm taking the x and I'm plugging in the 3, and I'm taking the y and I'm plugging in the 1, and then check to see if this is actually correct. And the answer is this is 6 minus 3, which equals 3. Oh, look, they match. Yay! I'm going to give myself some space down here. We can check the second equation. So in the first problem, we've got a single answer. If we've got a single answer, then my question for you is, what kind of a system do we have? Are they parallel lines? And the answer is no. If we got an answer, that means they're not parallel. Okay, are they the same line? And the answer is no, they're not the same line because we got a single answer, which means one of them goes up like this and one of them goes down like this, and we get a single point in the middle. So Matt Damon is saved. Woohoo! And just as quickly, there goes Matt Damon being in trouble again. Okay, now this problem is a little bit different. My first equation looks like 2x minus 3y equals 10. And my second equation is 3x plus y equals 15. In order to use substitution, let's look back at what we had in the first problem. In the first problem, I had one of the equations actually solved for one of the variables. It said x equals. So what we're going to do is we're going to come down here and look at these two equations. And if I look through, I see that neither one is x equals or y equals. But equation number 2 has just a y in it. And I think I could solve for that. So step 1, solve for one variable. You only have to pick one variable in, I'm going to draw a line so I've got space on the other side. You only have to draw one variable in one equation, solve for that. So I've got 3x plus y equals 15. Subtract 3x from both sides. Y equals negative 3x plus 15. Okay, I have solved for one variable. I solved for y. And this is in the second equation. So this is equation number 2. So step 2, substitute this into the other equation. So I'm going to consider 2 is the yellow equation. So that's the yellow equation. And 1, let me see if I can find my blue highlighter. 1 is going to be my blue equation. But you know how I love to color things. So I solved for y in the yellow equation. So I'm going to go to the blue number 1 equation. 2x minus 3y equals 10. I'm spreading it out so I got lots of room to look at things. And I'm going to go ahead and substitute. Now, mathematicians say substitute, but most human people say plug in. So the other word is plug in. We're going to plug in y. So I've got 2x minus 3. Now, in the place where the y was, right there, that y becomes, oops, backwards. That y becomes negative 3x plus 15. So if I were going to underline everything, I would say, okay, this part is the first equation. And this little part in here is us substituting in the second equation. So we've mixed the two equations. We're combining the two equations. This is called substitution or plugging in. Now, this is not going to be easy. This is a lot of work. In fact, I've got a negative 3 on the outside, which means I got to worry about sign changes and all. So this is not intended to be an easy method, but this is an exact method. You'll remember the first section, we looked at graphing to solve, and that gives us a basic idea, but it doesn't give us the actual exact answer. This technique will. So it's going to be a little bit extra algebra to get that exact answer. Okay, so I got 2x. Now remember, this negative 3 is going to multiply through. We're going to use the distributive property. Negative 3 times negative 3x is a positive 9x. Negative 3 times positive 15 is a negative 45. All that equals 10. If I combine these, I get 11x minus 45 equals 10. And the last step will be to add 45 to both sides. So we get 11x equals 55, or x equals 5. Okay, now I'm totally running out of space here, but I'm going to try to see if I can squish it in because it's going to make it easier. I'm going to take this x equals 5, and I'm going to go back over here to the first step and find that equation where I solve for y. Y equals negative 3x plus 15. So I plug in negative 3 times 5 plus 15 equals negative 15 plus 15 equals, surprisingly enough, 0. So my answer right here is going to be 5, 0. That was unexpected. So I'm going to give that a moment, and we're going to come back to the other page, and I'm going to write down the two equations, 2x minus 3y equals 10, and 3x plus y equals 15. So we can go on to check. We want to check the 0.50. This is for the second problem. Notice that when I go to check, I need to check the original equations. These are the equations as they were written in the problem. I have to check the originals because I don't know where a mistake might have been. So you'll always check the originals. Okay, so let's check here. I've got 2 times 5 minus 3 times 0. Does that equal 10? So let's check. 10 minus 0. Yes, it equals 10. Yay! Woohoo! Okay, let's check the second equation. 3 times 5 plus 0. Does that equal 15? 15 plus 0 equals 15. Yes, it does. Yay! So we have checked this answer. The ordered pair 5, 0 is the solution, which means Matt Damon is saved. Woohoo! Okay, join us later. I will give you yet some more practice with substitution. Woohoo!